Dave Staublin here. We're working on some good math, in particular finding an oblique asymptote. Let's say we have the function f of x equals x squared plus 3x plus 2 over x minus 2. Now, let's put this in our calculator and see what this looks like when we graph it. So there it is. I'm going to push the graph button, and it looks like we have an oblique asymptote. So just do a rough draft here. Well, and the other thing, it looks like we have a vertical asymptote at x equals 2. And then we have some sort of oblique asymptote, which looks like this. And so it appears that there's the oblique asymptote. We need to find the equation for that. We know the vertical asymptote is at x equals 2, but we need to find the equation for this line. Okay? So how we're going to do that is we're going to divide the denominator into the numerator. So x minus 2, we're going to divide that into x squared plus 3x plus 2. So let's see, multiply by x minus 2x. So that's a 0, and that becomes a 5x. Bring that down, multiply by 5. So we get a 5x minus 10. And we subtract, and that looks like 0, and that looks like 12. So we have a remainder of 12. This improper rational function will reduce to x plus 5 plus 12 over x minus 2. Alright, so here's what I want you to notice. When the x value gets really big this way, or really small this way, the bottom of the fraction, or the denominator, gets really big, and when you take a number divided by a really big number, this gets smaller and smaller and eventually goes to 0. And what we're left with is this x plus 5. And I think that's what the asymptote is going to look like. So let's find out. Yep, there it is. This asymptote is given by the equation y equals x plus 5. You'll notice that's a linear function. It looks just like mx plus b. So here's the deal. Here's the drill. Whenever you divide these fractions out, if you get a remainder and this denominator is 1 degree less than the degree of the numerator, you're going to get a remainder that looks like this. It's going to go to 0, and you're going to be left with a linear oblique asymptote.